Hi, and welcome to the Library Facilitation Guide video for Adaptation, A Way of Life, an activity from the We Are Water collection in the Star Library Network's online STEM activity clearinghouse. This video will walk you through the activities and demonstrations included in Adaptation, A Way of Life, as well as providing tips and tricks for facilitating Adaptation, A Way of Life at your library. This and many more activities are available on the STEM Activity Clearinghouse, a link to which you can find in the video description below. Adaptation, A Way of Life is an activity for elementary, tween, and family audiences that takes about 10 to 20 minutes to prepare and 40 to 60 minutes to complete. All of these activities and demonstrations can be set up as a station in your library or run as a facilitated activity. You can find tips for how to set up these activities as stations or facilitated activities in the PDF version of the activity guide, a link for which is in the video description as well. First, let's go over some of the background concepts and vocabulary you might need to help facilitate Adaptation, A Way of Life at your library. First, let's discuss what an adaptation is. An adaptation is a body part or behavior of an animal or plant that helps it live in its environment. For example, a bobcat has the ability to leap up to 6 feet in the air to capture its prey. A bobcat also has a spotted coat that allows it to hide in many different types of vegetation. Plants can have adaptations too, like a prickly pear's shallow roots that let it absorb as much rainfall as possible in dry climates. Another example of an animal adaptation is how a sagebrush lizard basks in the sun in order to absorb warmth. This aids in its ability to metabolize its own food as it cannot generate its own heat to aid in its metabolism. The next concept you should be familiar with when facilitating Adaptation, A Way of Life is the concept of succulence. Succulence describes plants with fleshy tissues inside their leaves that help them conserve water. Examples include aloe vera, the prickly pear cactus, and the banana yucca, all of which can be found throughout the Four Corners region of the southwestern United States. Another concept you should be familiar with before facilitating Adaptation, A Way of Life is the concept of evaporative cooling. Evaporative cooling is the process of lowering the temperature of something by the transformation of liquid water into water vapor. Dogs and many other animals use evaporative cooling to cool themselves through the process of panting. Humans also use evaporative cooling through sweating. The sweat that is released from our glands evaporates into water vapor, cooling our skin and cooling us in hot environments. If you live in a hot, dry part of the world, you may have seen a swamp cooler before. These are machines that use evaporative cooling to pass dry, hot air over cooler liquid, causing some of that liquid to evaporate and creating colder air that can then be blown into an indoor space. The final concept you should be familiar with before facilitating Adaptation, A Way of Life is the concept of being nocturnal. Nocturnal describes plants or animals that are mostly active at night. Examples include the raccoon and the great horned owl. Now, let's demonstrate some of the activities included in Adaptation, A Way of Life. First up, let's talk about the two-part demonstration, Plant Adaptation Succulence. These demonstrations can be done together or separately, and you can find instructions on how to set them up as a station in the printed PDF version of the Facilitation Guide available in the video description below. Let's go over the materials you'll need for both Part 1 and Part 2 of this demonstration. For Part 1, you'll need a square of wax paper, some paper towels or napkins, a sponge or eyedropper, a little bit of water, and optionally some masking tape for securing the wax paper and the napkins, and if you feel like it, a cactus or other succulent plant you can use to demonstrate how real succulents work based on your model. For Part 2, it's virtually the same materials. You'll need a small blackboard, a square of wax paper, a small paper towel or napkin, a sponge or eyedropper, water, and a timer. Additionally, optionally, you can include some masking tape to secure the wax paper and paper towels to the blackboard. And if you want to include, again, a cactus or other succulent to model what a real succulent looks like along with the demonstration, that can be very helpful for your participants understanding how succulents work. Let's go over part 1 of the demonstration. For step 1, you need to gather materials for the activity. If you're doing the activity outdoors or in a drafty area, you may wish to secure the paper towel or napkins and wax paper to your work surface using masking tape. If you're setting up this activity as a station or facilitated activity, you can tape many of these to a table well in advance in preparation for your patrons. Step 2. Using the sponge or eyedropper, sprinkle some water on both the paper towel and the wax paper. After sprinkling the water on the paper towel and the wax paper, you will see that the waxy coating of the wax paper acts similarly to the outside of succulent leaves, repelling the water and keeping it from being absorbed by the paper, while the paper towel absorbs and retains water like the fleshy interior of succulent leaves. Some examples of questions you could ask your patrons while doing this demonstration are, what do you observe? How is the wax paper similar to the leaves of succulent plants? How is the paper towel like the fleshy inside of succulent leaves? Now let's move on to the second part of this demonstration. First, gather up the materials for the activity. Then, using your sponge or eyedropper, sprinkle water on each side of the blackboard. It may be helpful to label the blackboard with which side you're going to put the paper towel on and which side you're going to put the wax paper on. Next, quickly cover the water with a paper towel and a piece of wax paper. Then, set a timer for 3 minutes and leave the succulent model to sit until it goes off. This would be an excellent time while the timer is going to do the Desert Adaptation worksheet included on the STEM Activity Clearinghouse page for this activity. After your timer goes off, observe your results. Here's what you should see. Much of the water underneath the napkin will have soaked through the napkin and evaporated, while most of the water underneath the wax paper will remain. Ask your participants, what do you observe? Why would it be important for succulent leaves to have a waxy, water-resistant coating like the wax paper? Are either of these adaptations enough for succulents to survive in dry deserts? How would these adaptations, both the waxy coating on the outside of a succulent leaf and the fleshy water-retaining interior, work together to retain water in dry desert environments? Let's move on to the next activity included in Adaptation: A Way of Life, the prickly pear model. This is a model of a typical cactus leaf that uses most of the same materials as the previous demonstration. You can provide materials and the instructions from the PDF copy of the Facilitation guide to run this as a station. First, let's gather our materials for our prickly pear model. You will need 2 large squares of wax paper about 10 to 12 inches in size, either cut from a large roll of wax paper, or you can use deli sheets that are sold in large packs of already cut sheets of wax paper. Paper towels or napkins, about 5 to 10 per model. We recommend using green paper towel or napkins so that your cactus model comes out green. You'll also need 20 to 30 toothpicks to represent the needles of the prickly pear, tape or glue, and a set of scissors. Step 1 of your prickly pear model. Secure the edges of your 2 sheets of wax paper together with tape or glue along one edge. Then, cut the joined sheets of wax paper into the shape of a prickly pear leaf. Next, secure the edges of your 2 sheets of wax paper up the sides, leaving a gap at the top of your prickly pear leaf for the paper or towels or napkins to be stuffed inside. To make the fleshy interior of your prickly pear, crumple your green paper towels or napkins to give them volume. Then, stuff your crumpled paper towels through the gap you left at the top of your prickly pear model in the previous step. Using your tape or glue, finish securing the edges of your wax paper sheets together. Then, you can begin poking holes with toothpicks through the wax paper. If your wax paper is particularly thick, you may need to use something other than a toothpick, like a darning needle, to pre-poke your holes in the wax paper. Next, add toothpicks to your prickly pear leaf model in clusters of 2 or 3 needles. Continue adding clusters of toothpick needles until one or both sides of your prickly pear leaf are covered in needles. Ask your participants, how do the 3 adaptations modeled in your prickly pear leaf, needles, the waxy coating of the leaves, and the absorbent interior, help a prickly pear survive in the harsh, dry desert environment? Next, let's talk about a pair of short demonstrations of shade and leaf angle and panting and sweating. These can be done together or separately, and again can be set up as a station using the instructions in the PDF facilitation guide available in the video description. Let's start with the shade and leaf angle demonstration. First, take your hand and a source of light and angle your hand so that the flat of your palm is directly facing a source of light. Point out which part of your hand is receiving the most light. Next, angle your hand so that the thumb or pinky is facing the source of light instead, moving your hand about 90 degrees from its previous position. And again, point out what part of your hand is receiving the most light. This activity models how the angle of the leaves of desert plants relative to the sun controls how much light and heat energy is absorbed by those leaves. In the hot desert sun, which leaf orientation would receive more light and heat quicker? Think about how heat affects water evaporation. Why do you think desert plants might need to regulate heat? Many desert plants angle their leaves parallel to the sun's rays, so the thin edge of their leaves absorbs the sun rays rather than the broad, flat surface of their leaves. This helped keep the desert plants from getting too hot. Now let's talk about the second part of the demo, panting and sweating. Extend your arms out on either side of your body. Using the sponge, spray bottle, or eyedropper, sprinkle some water on one of your arms. After one of your arms has been wetted, flap your arms up and down, like you're trying to take off with a set of wings. As you move the wet arm up and down, you should feel a cooling effect on the area of your arm that is wet. This feeling is evaporative cooling occurring as the water on your arms turns into water vapor. Ask participants in this demonstration, how do desert animals stay cool? Do many desert animals sweat? If not, why? The answer is, it is hard to find water to drink in the desert to replace the water lost from sweating. Many desert animals, such as coyotes and mountain lions, pant to stay cool instead. The next activity, the Create a Desert Creature extension, is a creative art activity that can be completed with any paper and art supplies, and easily set up as a station by providing the supplies on a table along with some simple instructions to your patrons. This creative art activity extension asks your patrons to design their own desert creature using their knowledge of useful desert adaptations. So this is especially useful after you've covered different activities in the Adaptation A Way of Life activity guide. When designing their creatures, ask your patrons, what does their creature eat? How does it capture food that it eats? How does it stay cool during the day? Is it more active during the day or at night? Here's an example of one, a rigged rabbitoise, which has wings like a falcon to reach fast speeds when hunting for prey, a tortoise-like shell to protect its body from getting hurt, and the body and legs of a rabbit to run at quick speeds in short distances. These are all useful desert adaptations that our winged rabbitoise will use to survive in the harsh desert environment. What are other adaptations your desert creature could use to help survive in the harsh desert environment? The final activity we will be discussing is the Desert Adaptation Worksheet. This is an alternate version to the worksheet included in the original Adaptation A Way of Life activity and can be found on the STEM Activity Clearinghouse page for Adaptation A Way of Life. This worksheet is perfect to be completed while other portions of activities are waiting to be completed, such as the evaporation portion of the Succulence activity from earlier in this video. This is also very easy to set up as a station by providing these worksheets as a station with instructions on a table. This worksheet invites participants to use the lessons they've learned from other parts of the Adaptation A Way of Life video and apply it to identifying plant or animal adaptations from the Four Corners region. Some examples of adaptations participants could identify include the spines of the prickly pear, the large eyes of the bobcat, or the shade-giving leaves of this tree. Encourage creative answers from your participants. Ask them to justify why they are identifying this as a desert adaptation on the plant or animal they are pointing out. Thanks for watching. This video was developed by the National Center for Interactive Learning at the Space Science Institute. Be sure to subscribe to STARNet and check out our other how-to videos here on YouTube. If you want more ready-to-go science activities, be sure to check out the STEM Activity Clearinghouse at the link in the video description. For more resources and advice on STEM library programming, be sure to check out the STARNet blog. The link is also in the video description.